Let's talk about polynomial inequalities, and let's just jump into an example. We're going to solve x squared plus 6 is greater than or equal to 5x. We are much better at figuring out when things are 0 or positive or negative, so I always shuffle everything over to one side of the inequality. You can choose which side. I'm going to go left, so x squared minus 5x plus 6 is greater than or equal to 0. I'm going to switch out the inequality for an equality because I am pretty good at this point at figuring out when things are equal to 0. And you are too, because you've done a lot of practice on solving quadratic equations. I think this one factors how's an x minus 2 times an x minus 3 sounding. Yeah, because I get a minus 5x in the middle and a plus 6 at the end. Okay, so that means x equals 2 and x equals 3 are where this inequality or this equation is 0. Now I want to know when it's greater than or equal to 0. So the only places that a polynomial function, in particular this is a quadratic, can change signs from positive to negative or negative to positive is a place where it crosses the x-axis, or in other words, is 0. These are continuous functions, so it can't magically jump from positive to negative without hitting the x-axis, which is 0. So in other words, 2 and 3 are the possible places where this could change sign. So I am going to build myself a little number line, and 2 and 3 are the places that I care about. Okay, so again, let's think about the function f of x is equal to x squared minus 5x plus 6, which is equal to, we factored out, x minus 2 times x minus 3. Now, I only care whether it's positive or negative, so I'm going to pick my favorite number to the left of 2. I'll go with x is equal to 0. Pick any number you want as long as it is to the left of 2. I'm going to then plug that into f of x, and all I care about is whether it's positive or negative. So 0 minus 2, that's negative, and then 0 minus 3, that's also negative. So I have a negative times a negative, which means overall, over here, that function is positive. Pick your favorite number between 2 and 3. I'll go with 2.5. Plug that into your function f. Again, only caring about the sign of it. 2.5 minus 2, that's a positive number. And 2.5 minus 3, that's a negative number. So I have a positive times a negative. So overall, in between 2 and 3, this function is negative. To the right of 3, pick your favorite number. I'll go with x is 5 for no good reason. 5 minus 2, that's positive. 5 minus 3, that's positive. So I have a positive times a positive. So over here, I'm positive. Okay? So now if we think about, do I want positives or negatives? Well, we had turned our inequality into x squared minus 5x plus 6 was greater than or equal to 0. So I want the positives. Those happen to the left of 2 and to the right of 3. And it was greater than or equal to, so I get to include them. So my solution is negative infinity up to 2, greater than or equal to 0, so I get to include the 2, and then union 3 off to infinity. Okay, so those are the places where the inequality that I started with worked. Another way that you could think about this, because there's a lot of ways to think about the same topic, is I had built a number line here, but the other thing you could think of is, well, I know what x squared minus 5x plus 6 roughly looks like. I know it's a parabola, and I know it opens up because of the 1x squared, and I'd already found the zeros of 2 and 3 because I had set it equal to 0 and solved, so I know over here, here's 2 comma 0, and then over here is 3 comma 0, and it opens up. So it looks something like this. And I wanted to know, originally, when was this thing greater than or equal to 0? Well, that is greater than or equal to 0 over here, because it's above the x-axis, and same with over here. So that tells me to the left and of 2 and to the right of 3 that that thing is greater than or equal to 0. So I could have come to the answer of negative infinity to 2, union 3 off to infinity, inclusive on the 2 and the 3, from a visual representation as well. So number line works, visual representation works, but either way, your goal is to get everything to one side, so you're essentially comparing to 0.